Good morning, everyone. Welcome to this first TALOS Info Day about the TALOS Open Call. First of all, thank you for joining us and for your interest in the TALOS Open Call. Uh, we will need to let you know that this webinar is being recorded and that later it will be available at the application site for everyone to check it. Well, we would like to explain a bit about the TALOS project, the TALOS Open Call, and the TALOS pilots and the challenges that will be solved through this Open Call. We will start with, well, here we have Daniel Albuquerque, coordinator of TALOS project, and Claudia Fernandez, also from EDP. My colleagues, Patricia and Anna, that help us with the organization of the open call. Well, we will give the floor now to Daniel to start introducing the TALOS project. Thank you very much for joining us.
Good morning, everyone. Thank you, Yolanda. I'll now share my screen. Hope you can all see it by now.
Yes.
This is the case. Nice. So, TALOS. I'm the coordinator of this project. This is an European project that has started for around 1 year by now. The project will last for 3 years. It has a total budget of 10.5 million. For the open call in particular, we have almost 2 million to distribute to startups and SMEs all around Europe. The technology level that we are trying to assess is to have a TRL of around 6 to 7 by the end of the project. The same applies to the technologies that are being developed during this open call. TALOS is all about robotics, especially autonomous robots and digital solutions that are applied to the PV sector in order to automatize and reduce human intervention in the O&M sector, so the operations and maintenance of these PV parks. We have different set of PV parks in TALOS. We have floating PV, so PV panels that are above the water bodies of, for instance, dams. Then we have the conventional PV, the ground-mounted PV, and we have also a scenario of agri-PV, where we are testing a little bit the duality between food and energy production. Regarding the consortium of this project, we are 13 main beneficiaries from 6 countries around Europe. From Portugal, we have EDP and Dineshktech. EDP is the coordinator. Then from Spain, we have DTA, Isotrol, Alices, and Resch. Then from Luxembourg, we have Solar Clino, Wageningen University from the Netherlands, Funding Box from Poland, Icons from Italy, and then from Greece, we have CERT, Edencor, and the Agricultural University of Athens. This is a pretty big consortium already, and it covers more or less everything related with the value chain of PV. So we have the end users like Resch, which is an O&M provider, and EDP, so asset owner, a PV asset owner. Then we have R&D centers, we have robot developers, digital platform developers, communication and dissemination partners, open call experts like Funding Box, who is helping us with this open call, and universities as well. Regarding the motivation that is behind the project itself, there are 4 main motivations. The fact that we have PV at a bigger scale. So In the beginning, the PVs were quite small, so we are talking about a couple of megawatts, and nowadays we can have parks of a couple of gigawatts. So a lot of has happened during the last decade, and the growth of PV is quite evident. At the same time, the location of these PV installations are being installed in very remote places, so it also gives us some challenges in how to address challenges and give the proper operation and maintenance tasks to these parks in such remote places. Um, at the same time, we are facing quite a shortage in people, in people that are experts in O&M. So that's quite challenging as well. And again, having these people close by or even travel to these remote places. And finally, the fact that these PV plants are no joke. So we are talking about danger places, and we want also to prevent any kind of injuries or even worst cases. So the main objectives for the project, we want to develop robots. So world-class world-class quality robots to basically do different O&M tasks in PV parks. We want also to develop some AI-based algorithms, so digital tools that can help in detecting and detecting anomalies and bring this PV operation close to the optimal point every time. Regarding the operations that we are considering, so the tasks that we are tackling within the project, we are considering monitoring, the inspection of the assets, uh, its cleaning as well, and some vegetation management. So we have these four main O&M tasks that are being automatized and for which we are creating robots or AI tools that can operate in an efficient way and try to mitigate also some potential accidents that may occur to operators. Then the fourth objective is to study a little bit this duality between energy and food production. As I told you, this is a subject that we want to study quite deeper in our agri PV pilot. Then this was quite evident in the call that we wanted to co-create all these robots together with the end users. So the idea is to have robot developers working together with the end users, so we can have this co-creation purpose at the same time that we make sure that everything that is being developed um, is taking into account all the needs and the pains that the end users already have. Last but not least, we have this 1.8 million for this open call. So the idea is to have a lot of startups and SMEs all around Europe to develop other solutions that the ones we are already developing inside the project, and to increase a little bit and broaden the scope and ambition of the project. Regarding the developments we are already making in the project, there are different domains, and I'd like you to give more or less an idea of the different solutions we are already considering. Regarding the interaction between robots and humans, we have 2 or 3 main platforms already being developed. We have multi-engine environments with human in the loop. This is being developed together with the TALOS platform, which is basically the digital brain of the project. And then we have the digital twin and this topological scene understanding. So it is quite important to have these digital twins to be always trying to simulate a little bit what's happening in real time in the PV plant, but also testing different scenarios for the future. The topological scene understanding is also quite important since we have robots that are being deployed and we need to understand if topological the terrain is still operational from this point of view, for this robot point of view. Regarding the PV monitoring and in inspection, we want to develop these AI algorithms that I have told you about in a couple of minutes ago, where we want to do some automatic detection of problems that happens both on the PV side but also on the infrastructure side. And then we have this edge intelligence on the drones that will have especially for the inspection of the assets. And we'll also be designing this recommendation engine for operation and maintenance sections, where it takes into account all the data that we have and all the knowledge that we are building, and then try to recommendate actions directly to the O&M teams that are responsible for those parks. For the different scenarios that we are tackling this problem. For the land-based PV itself, we are developing mainly 2 robots, one robot for cleaning and another one for mowing, so to do this vegetation management. For the floating scenario, we'll have a drone and 2 other robots. We'll have a cleaning robot for the specially designed for this floating platform, and also an autonomous boat that can deliver this drone closer to the platforms. For the last domain, which is the agriculture one, in this agri-PV scenario, we will be more looking into the monitoring and inspection. And for that, we are developing a device that monitors all the crops and the different stages of that crop, and can also propose some actions on the agricultural parts, such as pruning or harvesting, etc. Besides this device, we are also developing an autonomous vehicle that can operate on the ground and have this device and also other sensors to inspect and operate through the pilots. Sorry, I skipped one slide. So regarding the tasks that we are fully operating in the project, as I told you, we have this monitoring, inspection, cleaning, and vegetation control. But here I give you some images of the kind of solutions that we are developing. So for the monitoring part, we'll have the first robot for the agricultural pilots. This is a husky robot that is adapted to this environment, and on top of that, we have different sensors and devices that can scan and do some monitoring on the crops. Then on the digital part, we'll have our digital brain, the TALOS platform, alongside the SCADA data that is being integrated in this platform, together with the digital twins that are also running in this platform. For the inspection, we are mainly using drones. These drones will have different kinds of cameras and sensors to do also different types of inspections on the visual spectrum, but also thermography inspections, and hopefully also some thermal luminescence as well. Regarding the cleaning, we have different solutions. For the conventional PV, we'll have something like this, so quite a big robot, a big vehicle that in this picture you can see that there is a person there, so this is not exactly the solution that we are creating. developing. As it's here mentioned, this is just for illustrative purposes, but it's something big that it also fits the size of this conventional PV. So we are talking about we are talking about cleaning at scale. Then we have different solutions for the floating PV. For the floating PV, we are talking about a robot that is quite smaller, that can be put on top of the panels and can just go through the different strings and clean them. At last, we have this vegetation control. Again, these images are images of maybe remotely operated and semi-autonomous solutions that are commercially available, but this is not exactly what we are developing. We are developing, again, something for a bigger scale. So the robot will be quite bigger than this and will be fully autonomous. Regarding the major impacts that we have in TALOS, on the scientific realm, we have this robotics part where we want to develop world-class robotics to address these O&M challenges. Then on the decision support tools that we are creating, this is also something that we want to add to the existing solutions that already exist on the market. So our idea is to the main focus is on the predictive maintenance, and we also want to create new methodologies for this autonomous operation of robots in PV parks, together with some agricultural purposes as well, especially on the agri-PV scenario that we have. And we believe, as the Commission believes, that agri-PV is the future as well. So to have multiple use for the same land. On the technological parts and economical, we want to increase the reliability and availability of these PV plants. So the idea is to perform some of these O&M tasks, especially the cleaning during the night, so we can increase this availability. So we don't have to do it and to cut production during the day and have people there. So the robots will be completely autonomous and they can operate during the night to fulfill these needs. And finally, we want also to reduce the costs for O&M. As I told you, the parks are getting bigger and bigger, and the costs of O&M are also increasing quite a lot. So if these places are being installed in some remote locations, to have people there, it also they can go, but at a cost. So we can also we want also to change this a little bit. And we want also to finally to show to the farmers that they can have an increased value with PV panels being installed on their lands. Finally, we want to de-risk a little bit these autonomous O&M interventions. So we want to make sure that autonomous O&M is something that is feasible and that is scalable as well. And we want to make sure that we can, in fact, reduce the exposure of human operators to these some difficult environments. Again, we are talking about energy power plants. There is also some difficulties and some dangers around, especially for the floating PV, where we have electricity production together with a big water body just below you. So it's difficult to operate, and it has a lot of constraints as well. So we want to mitigate any kind of accidents that may occur. And we want also to reduce this intervention or this need of human operators being always on site. With this, we want to lower a little bit the emissions that we do normally using these or having these tasks ongoing. And we also are developing some programs to do the upskill of the workers that currently are responsible for the O&M of PV parks. So the main outcomes of the project, we want to reduce the human exposure, as I told you, the emissions. We want to reduce the O&M costs. We want to increase these the efficiency of our parks. We want also to understand if the panels are always not always cleaned, but at least with the more frequent cleaning actions that they usually have, if we can increase a little bit the life cycle of the PV panels. And for the water that we use for the cleaning, we want also to reduce a little bit the amount of water that is being used with new techniques and new kind of brushes and etc. So this is it about the overall context of the project. Now I'll go a little bit deeper on the pilots that we have. For the conventional PV that we here call it land-based PV, we have two hybridization plants in Spain. We have they are very close to Madrid, maybe 1 hour nearby Madrid, which are in Villacastín and Cruz de Hierro. These hybridization plants are a mixture of PV and wind, but for the purpose of the project, we are only using the PV part of these plants. So in each plant, we have 14 megawatts. In total, we have 28. And for this scenario, we are developing a drone to do aerial inspections on the sites. We have this bigger cleaner that can operate at scale, and also a bigger mower that will basically do the vegetation cutting, but also will collect all that vegetation. Then we have two pilots for the floating PV. The first one is this Alto Rabagão in Portugal. In fact, this pilot was the first floating PV in a hydro dam in the entire world back in 2015. It is quite small. We are talking about 200 kilowatts around it. And for this scenario, we are considering the developing of three main solutions. Again, a drone that can do aerial inspections on the site, an autonomous boat that can navigate this drone from the shore closer to the platform. And then we have a cleaner, so an autonomous version of what we can see in the image here. And that's basically it for Alto Rabagão. Then we have Alqueva. This is the second floating PV pilot site that we have, also in Portugal. This is the largest floating PV in an artificial lake in Europe. So we're talking about 5 megawatts. And the solutions will be quite similar to the first floating PV, so a drone, a cleaner, and an autonomous boat. This more on the hardware parts. Finally, on the agri-PV, we have these pair arcades in the Netherlands. This is an asset from the Wageningen University. For these pilots, we'll have these bifacial semi-transparent PV panels. And this is the smallest pilot that we have. We are talking just about 50 kilowatts. And it is quite a new infrastructure. So there's also some challenges that will certainly will face during this project. For this particular pilot, we are developing a drone to do inspections on the PV panels, and also we are developing the Husky robots, and we are capacitating it to have different sensors for crop monitoring. And I believe that's all for my part.
Thanks so much, Daniel. So then I can go through the open call. I will try to share my screen. Mhm. Okay, so well, now I will present the open call that I know is the main interest of the attendants to this info day. So, well, TALOS Open Call will open the 30th September, and the deadline is the 3rd December at 15 Brussels time. It's important to all the applicants to know this date and time because at the exact time the system closes automatically and it's not possible to submit the applications after this. Mm. Well, who can apply to this open call? We are looking for individual entities like small and medium enterprises and startups. These companies should be registered uh, in one of the following countries: the member states of the European Union or his overseas countries and territories, or in one of the associated countries to the Horizon Europe program. And what will the beneficiaries of this open call do? They will develop robotics, artificial intelligence, and data solutions in order to address one of the challenges that have been defined by the TALOS Consortium for the three project pilot scenarios, the three pilots that Daniel has just explained. And later, Daniel and Claudia will explain us what this, I think, is 16 challenges are. Okay. Mm, what are the benefits of this open call? The startups will be covered for all their eligible costs up to 2,000 euros. Sorry, 200,000 euros. And small and medium enterprises that are not startups can receive up to the 70% of their eligible cost. That is 140,000 euros. Also, the beneficiaries of the TALOS Open Call will join a 9-month support program, and during this support program, they will receive technical support from the TALOS technical partners. These technical supports will be about engineering integration, testing, and validation to support the selected companies to demonstrate the added value of their solutions. Where can you find more information about the open call? At the application site, you have a tab that takes you to these useful documents, the guide for applicants, that is the legal basis for the open call. We recommend you to read it thoroughly, all the eligibility criteria, evaluation process, how is the support program, everything is explained there in detail. Then you have another document that is the frequently asked questions. And here you can find some questions that usually arise during the application process. Okay. Well, also you will have, for example, examples of budgets that can be used for the application. Lately also you will find a draft or an example, the subgrant agreement template, that is the contract that will be signed among the TALOS consortium and the beneficiaries of the open call. This is not available yet, but it will be available through the duration of the open call, okay? And well, how to apply to the open call? You just need to go to the application site, click the Apply Now button. If you don't have an account in the Funding Box platform, you will be asked to create one, but it's a really simple, straightforward process. Then you will have the option to start a new application. You will fill it, click Submit, and that's all. This is what you will see when you click Start a new application. Okay, you will see these 9 sections. The ones that are marked with a red star are mandatory. only the statistical section is not mandatory, but we will really appreciate it you fill it because it helps us a lot in getting to the applicants. Mm, when you click one of the sections in fill, you will see the section to be filled, okay? This is the first one, for example. Again, you will need to fill all the questions that have a red start. After filling each section, you should click Save and Continue. I have to say here you have the option to add a contributor. Another person from your company can help you in filling the application form. It's important that after filling each section, you click the Save and Continue, because if not, the other contributor will not be able to see the questions that you have included already. When you have filled all the sections, you will see it like this. And in that moment, you can click the Submit Now button that you see in the bottom part, and then your application will be submitted. Some tips. You can submit your application and then you can edit it at any moment before the deadline. So that's why we recommend to submit in advance. And if then you recall that you can improve something or whatever, you can do it always before the deadline. Don't wait until the last minute to apply, okay? Because sometimes, well, we have some complaints like, oh, I was trying to apply only 1 minute after the deadline and it was not possible. Yes, it is not possible to apply after the deadline, okay? For this open call, each company can apply a maximum of 3 times, but each application has to be to a different challenge. If we see that one company has applied twice for the same challenge, only the last submitted application of those two will be admitted to the selection process. Okay? As said, you can also always edit the application form before the deadline. And well, as explained, you can add contributors to your application. And what happens after the submission? When the call is closed, we start with the selection process, okay? First check that is done is a general check that you have submit all the parts of the application, that is completely in English. Well, we see that all the basics that are stated in the guide for applicants are fulfilled. Then there is a step then in out scope screening that will be only happen if there are so much applications and TALOS selection committee understand that is necessary. In this case, one member of the selection committee will check the applications to see if they are in the scope of the project, okay? After this step, we will have the independent individual evaluation, where 2 external experts and 1 internal expert will evaluate each application. In this part, the sections of excellence, impact, and implementation are scored against the criteria that you can find in the guide for applicants, okay? Each section is scored from 1 to 5, and the threshold to pass to the next phase is 3 in each section and 10 in the total sum of the 3 sections. After this evaluation, we will create a ranking list with the scores reached, and the TALOS selection committee will discuss in the consensus meeting the proposal selected, the ranking of proposals. With this, they will select around 10 applicants to pitch their project in a jury day where each applicant will have the opportunity to pitch their project to the selection committee. After this jury day, TALOS selection committee will decide which applicants are invited to be in part of the TALOS support program. Okay. After this stage, also we will have with this initial or previous list of beneficiaries, we will have a formal check where we will ask you for some documents about your company to check your eligibility. And then the selected applicants that have passed this formal check will sign a sub-grant agreement with the TALOS consortium to perform the support program. Well, as said, the provisional list of beneficiaries, formal check, the sub-grant agreement signature, and then the support program will start. And how will the support program look like? The support program will last 9 months, and it will have 3 stages. In the first stage, the beneficiaries will develop this individual mentoring plan and the virtual prototype of his project. The second stage is called the solutions development. It will last 3 months. And the third stage, the longer one, will last 5 months and is when the beneficiaries will go through the solutions integration and demonstration. During all this time, the beneficiaries will have the technical support of some TALOS technical partners that will help them in the development of these solutions. Well, for the future, we are having another info day, the 9th of October, and we will also have 2 shorter webinars in how to apply to the open call. You are for sure invited to join us there. And well, all the information will be available in the future in the application site. Okay. We also would like to invite you to join us in the TALOS community that we have in Discord channel. There is a specific channel just that will be used as a help desk for this open call. So you can join us there and ask all your questions and see the questions that other applicants have. So we will wait for you there. And also, well, we have this help desk email that you can use if you have a question that is more private that you don't want to share in the Discord channel. Well, I think that's all from my side. Now I'm going to give the floor to Daniel and Patricia that are going to explain in more detail the challenges that have been defined by the consortium and can be solved by the beneficiaries of the open call. Thank you.
Thank you, Yolanda. Sharing the screen again. Can you see it?
Yes.
Okay. Sorry, but now I think, okay, now it's perfect. So now I'll go a little bit deeper into the challenges that we are basically that we have gathered within the consortium, and then we have these 19 challenges. Some of them are that they can be applied to any of our pilots. Others that are more specific to a given PV scenario, and we have in fact a final one that is quite open. So where we just give the floor to startups and SMEs just to give openness and we are free to apply with a different topic that you may believe that can also fit under the scope of the project. But I'll go a little bit deeper into each one of these 19 challenges together with my colleague Claudio. Before I go into that, just to tell a little bit how we set and how we are going to present these challenges. So the challenges are very vague, are just names of a challenge, and we wanted to be a little bit more specific and to give you also some hints on the kind of solutions that we were looking for. So we have defined some requisites, and we divided them especially into two forms of requisites, ones that are mandatory and the others which are preferential. I think the name says all. So basically, for the mandatory ones, we are basically creating some features or requirements that we believe that that solution should have. We may accept some solutions without some mandatory requirements, but they should be very well explained and justified why you are not fulfilling that specific requisite. For the preferential ones, this is some nice to have features, which, by the way, you should also met, since it can give the applicant some advantage in this evaluation process. So if we receive a proposal that is more ambitious than the other, of course, that we are considering it as a higher score than the remaining ones. Then we have two other types of requisites that you can see between these mandatory and preferential ones that are related to the demonstration part and others that are related with the integration part. What does this mean? Depending on the challenge I will now talk a little bit about these demonstration related requisites. Every time that we have a challenge, it is supposed to demonstrate, and it's also a stage on that three-stage period that Yolanda just presented. The last stage is this demonstration, where after you develop the solution, you demonstrate it, and the way to demonstrate it's usually in one of our pilots. And there are some challenges that we really want to have those solutions, your solutions, demonstrated in one of our pilots. But there are other challenges that we consider that they are more or less agnostic of the pilots, and they can be demonstrated in an equivalent site. So it doesn't need to be our pilots, the ones that we have in TALOS, but it should be in an equivalent site. So in another PV that you may have closer to your headquarters or something like this, or in a site that you know better, and you are more comfortable in testing in that specific site. So these are the requisites that are related with demonstration. So sometimes we have these as mandatory, sometimes it's preferential. At the same time, we have some requisites also for the integration part. As I told you, we are building and developing this digital brain of TALOS, the TALOS platform. And we believe that most of the digital and technology solutions that will be developed during this open call, they should be at least capable of being integrated with the platform. Sometimes we oblige that the solution should really be integrated in the platform, but others we just put this requisite as being capable. So we are not obliged to integrate your solution into the TALOS platform during the course of the open call, but in the future, if there is need of doing this integration, you are capable of doing it, and you should make sure that your solution complies with all the communication protocols that we are also setting for our platform. And this will in fact be part of the. I don't know if it will be exactly the guide for applicants, Yolanda. Maybe that there's a different document with this information, or is it in the guide for applicants? I think it's on the guide for applicants.
Yes, yes. It's in
It
the
is,
guide.
yeah.
It's in an annex to the guide for applicants.
Exactly. Okay. So yeah, this is basically the way we understood these requisites, and so you can also understand better the list of requisites that we are just about to show. Regarding the first challenge, we have considered this BV loss aerial inspection. So BV loss is this beyond visual line of sight. So basically drones that can inspect autonomously our PV sites. So this is a challenge that can be applied to any PV pilot that we have within TALOS. So it could be the floating, the land-based scenario, or even the agri-PV, you name it. You can choose exactly which kind of pilot you want to test this solution, but as the mandatory requisites, we want for this drone to must be able to execute flight missions completely autonomous. It should take into account the exclusion zones. So this is something I think pretty obvious as well. The solution should maintain these reliable communication links, and we should have real-time drone data transmission with our platform. It should have this capacity to integrate with the TALOS platform. Again, this is just the capacity to integrate and not the communication with the TALOS platform. The communication with TALOS platform we considered as a preferential requisite for this case. So the integration isn't mandatory, but the capacity to integrate is mandatory. And it should be validated in one of our pilot sites. So sorry, it could be in an equivalent, not ours. It could be in an equivalent pilot site. So as preferential requisites, we would like to see if there's these real-time inspections using different kind of sensors and cameras. So try to, if there's any drone startup or SME there, try to be bold and try to propose new solutions and with different kind of approaches, especially the ones that are not yet on the market or the ones that are not common in the market yet. Then we should have you should have real-time imagery data capture, so you can transmit those data to a computer or something that is on shore. The flight endurance should be above this 50-minute period. That would be great to see. And then the communication, as I told you, is a preferential. So this integration is something not mandatory in this specific challenge. And it would be nice if you could validate this in one of our pilot sites, especially if you could call to these sandboxing areas where we could ask the aviation entities responsible for that are responsible for the countries in which we have pilots, if we could go into some regulatory sandboxes and try to explore a little bit these autonomous drone flights. Now I give the floor to Claudia.
Thank you, Daniel. So now the second challenge here that we are proposing is also regarding drones, but it mainly pertains the autonomous inspection flights for electroluminescence imaging and analysis. This is also a challenge that is applied to all the different types of pilot sites, so floating, land-based, and also on agri-PV. And it should basically analyze and detect all the defects in the PV panels using these electroluminescence imaging techniques. So this is a mandatory, basically, to perform this testing during the nighttime. and also with cameras that are capable of having high resolution to detect all these defects, and the ability, of course, to diagnose and interpret all the data gathered from these types of testing. And similarly to the previous challenge, we also require the capacity to integrate within the TALOS platform, but not the communication as a mandatory requirement. And this is also something that we must do. So the challenges, the proposed solution should be validated in an equivalent or relevant pilot sites. Now, as a nice to have, these types of techniques could be performed during the daylight, and also automated approaches of current injections in the PV plants, or even the usage of a passive luminescence technique is also something interesting that we, of course, encourage you to explore. And also integrate here a possibility of having an advanced AI image processing software, all in this integrated and communicating with the TALOS platform that is in development, and it would be very nice to validate it into the sandboxing areas of our TALOS pilot sites.
Now, the third challenge that we have identified is this fire detection and deterrent system. This is a challenge that can also be applied to all pilots. So these three different scenarios: land-based, floating, and agri-PV. For this challenge, we wanted to have a system that can use different kinds of sensors to identify um, potential fires or potential problems that may occur or may potentiate a fire within these PV plants. We want this detection to be as fast as possible, and for mandatory requisites, we just set that we want this fire detection system. You can use whatever you may need, so sensors, cameras. If you want to have some data also from the SCADA systems, we can also provide that. So try to be, again, bold and try to propose something that would be smart and not very expensive, so we can also scale this solution to other PV parks. We request that this monitoring and control should be remotely done. The alarmistics, so this alarm system, should be integrated in this solution. Then again, the capacity to integrate with the TALOS platform is something mandatory, but the communication, the real integration, is only preferential here. And you can validate it in one of our pilot sites, but here the mandatory part is just in an equivalent to TALOS or relevant pilot sites. For the preferential parts and topics that we have addressed, we identified this automated fire suppression system. That is something that you could provide. That would be also great to see. I already told you a little bit about the communication, and the validation we know in one of our pilot sites is something preferential as well.
Now moving on to our first pilot site specific challenge, which is a deep learning based bird deterrent system, of course applied to the floating PV. And what we are looking for here is a solution for a very known problem, which is the degradation of the panels and the loss of efficiency due to the presence of birds and bird droppings. So we are looking for solutions that develop a system to detect and deter these birds from either nesting or interfering at all with the solar panels in a floating environment. And as a mandatory requisite here, we are looking for advanced AI bird recognition algorithms, a system that must repel the birds from the plants, mainly seagulls, and also doing all of this while not harming the birds physically. And we also here have the a must of this system must be able to be integrated within the TALOS platform, but similarly to the previous challenges, these both the communication with the TALOS platform and the validation in the TALOS pilot sites are only a preferential requisite.
For the fifth challenge, we have this autonomous detection of defects in another water power cables. The idea is to have autonomous underwater vehicles that could ensure efficient maintenance and reliability of this electrical infrastructure that we have, especially in this floating PV. So this is a challenge that is its focus is on floating PV scenarios. As mandatory requisites, we are looking for this solution to have the ability to identify these defects in underwater power cables. These vehicles should maintain reliable communication of data between itself and some computer located nearby. Then we have this ambition of having an endurance mission of above 30 minutes. So this should be something that we see as mandatory. The robot itself, the vehicle, should not affect the ecosystem on the water. And again, as mandatory, we see that this solution should have the capacity to integrate with the TALOS platform, and it can be validated in other pilot sites than the ones that we already have. So if you have any floating PV pilot site nearby, you can use it and to test and validate your solution. As preferential requisites, you see that you'd like to have detailed visual inspections over these power cables. Also to have the ability to diagnose any faults that may occur. And regarding the communication link, this is something that is just preferential, the integration with the TALOS platform. And if the validation occurs also in one of our pilot sites, this would be seen as preferential. Moving on to the sixth, Claudia.
So very similarly to the previous one, we have here a challenge that also uses autonomous underwater vehicles, but now regarding the inspection maintenance of the platform anchorages and the mooring lines. Basically the solution should provide autonomously operated vehicles, in this case, that are able to do these activities in harsh underwater environments that are less than 100 meters deep, and of course fully autonomous without any kind of human intervention. And as a mandatory requisites here, we have the ability to inspect the anchorages and mooring lines using different non-destructive techniques. And we are looking for a 3D mapping solution of all the anchorages and lines. And these types of systems, of course, must have reliable communication links and real-time data transmission. The endurance here, we also aim to have more or less a mission time of above 30 minutes, and all of these types of activities should not affect in any kind of way the underwater ecosystem. And similarly to the previously presented challenges, we are also looking for the capacity to integrate with the TALOS platform and the validation of the solution in an equivalent pilot site, having both the communication with the TALOS platform and the validation in the TALOS pilot site as a preferential requisite. And while we are looking at this preferential list, we also want to challenge you to find ways of autonomously cleaning both these anchorages and mooring lines and identify types of defects using AI algorithms. This is the main the main topics that we wanted to challenge you, of course. And moving to the seventh.
The seventh challenge is this prevention of algae growth and biofueling. So the idea is to have a system that could implement proactive measures to inhibit the accumulation of organisms on the floating PV platforms and also on the mooring lines and anchorages. So as mandatory requisites, we see that you should design a solution to prevent this algae growth. Um, it should be capable of identifying and measure the presence of algae, and it must not affect the underwater ecosystem. And this solution can be validated in an equivalent and relevant pilot site. As preferential, we see the integration of potential sensor data with TALOS platform and the validation in one of our pilot sites. For the eighth,
So in the challenge here, we have also applied to the floating PV pilot the remote environmental quality control, in which we are looking for a system that can measure and monitor the water quality to ensure all the compliance with the environmental regulation and to provide some indicators on marine fauna. And for this, we want to perform two quality measurements in different locations. One under the floating platform and another in a control zone further away from this platform in itself. And we are looking for parameters such as temperature, pH, dissolved oxygen, nutrient levels, and etc. And we want also have a model to forecast the algae growth and also the biofouling, and a system or algorithm that can perform fish counting within the same locations as I explained before. All of these, of course, while not affecting in any way the underwater ecosystem, and the validation of the solution in itself must be done in an equivalent or relevant pilot site. Now, as a nice to have for the preferential requisites, we are looking for other types of marine life statistics in these both locations as well, and also have or it should or could be it could have the capacity to differentiate different types of fish species, all integrating these sensors within the TALOS platform and also validating in one or more of the TALOS pilot sites. Now to the ninth.
thank you. The ninth challenge is related to extended reality tools for the operation and maintenance teams. So the idea is to have this digital tool applied to an Oculus or something like that, directly for the O&M teams to facilitate this monitoring, the remote assistant and collaboration between O&M teams, and especially while this solution provides real-time guidance on the on-site technicians. So as mandatory requisites, we have this capacity to integrate and communicate with the TALOS platform. So the integration is fully mandatory here. The validation in one of our pilot sites is also mandatory. The solution should have a virtual representation of the PV plant, access to real-time data from the TALOS platform. So we'll provide you data, and this data should appear in some way in the environment that you'll be creating. So we are talking both data from the PV plants, but also from the robots that are being deployed in each site. And augmented reality features for real-time data visualization from the PV plant, including alarmistics and also some robot mission progress. For preferential requisites, we see virtual reality for remote operation of these autonomous O&M tasks, and mixed reality features for robot mission triggering within the pilot site.
So now for the 10th, We have here a solution that involves all pilot sites, which is the pre-cleaning and soiling prevention coatings applied to PV panels. And these types of solutions should prevent the accumulation of dirt and debris on the surface of the solar panels. And we have some mandatory requirements, such as the coatings needing to be compatible and with the PV panels and non-corrosive. It should be durable with a lifetime of over 5 years, be biodegradable and environmentally friendly, and have a minimal impact on solar energy production, only accounting with a reduction of 1% in production of a baseline PV panel, and be easy to apply. This solution must be validated in one of the TALOS pilot sites, but since this is not a software, neither a robot, it does not need any type of integration with the TALOS platform, just validation. And a nice to have would be the monitoring stages of this soiling after the coding application. Now for the 11th.
For the 11th, we have similarly to the underwater, we have this challenge that is focused on the autonomous detection of defects in underground power cables. This challenge is quite open since we don't have any specific solution envisioned for this challenge. But yeah, the idea is basically the same, which is the detection of defects in these cables in the conventional PV. Okay. So for the requisites, they are very generic. So we want a solution that would have some defect identification capabilities using advanced AI algorithms or other techniques. And this challenge should be validated in one of our pilot sites. So since this is land-based, you are confined to the Villacastín pilot site in Cruz de Hierro in Spain. As preferential requisites, we would have this route mapping of the underground cables. It would be quite nice to have this mapping also performed, and the capacity to integrate and communicate with the TALOS platform. In this specific solution, we are not even considering the capacity to integrate as something mandatory.
Moving on to number 12. We have here a challenge on biodiversity applied to the land-based PV, which pertains the identification and monitoring of both flora and fauna of the local systems. And the mandatory requisites here are mainly regarding the identification of both protected plant species and animal species, and also having an alert system to basically send any kind of messages to alert for animal intrusions. And this should have the capacity to integrate with the TALOS platform, and also it must be validated in a land-based TALOS pilot sites in Spain. And as a preferential requisites here, we would like to see a baseline with data of already existing biodiversity in the area, and also communication, a direct communication with the TALOS platform.
The 13th challenge is about soil analysis using unmanned aerial vehicles, so drones or AGVs, so autonomous ground vehicles. And the idea is to perform soil studies to obtain information about its characteristics, so we can also make decisions for the robots. So we can understand better if it is safe for robots to operate in a given part of the plant. This is quite important since we need to understand if there are some parts that are, for instance, that have a composition of water that is too much for the robots to handle, especially if it is too muddy for the types of vehicles that we are considering within the project. So we can detect that and prevent some robots of being stuck in the terrain. So as mandatory requisites, we would like this solution to have capability of do some chemical and visual analysis of the soil. It should have a recommendation engine so we can operate our robots safely. Um, it should have the capacity to be integrated with the TALOS platform and must be validated in one of our pilot sites. As preferential requisites, we would like to see advanced AI algorithms to analyze this soil data. And it would be also nice if there was sample collections of soil to analyze its characteristics. Finally, the communication, so the real integration with the TALOS platform, we consider it as a preferential requisite.
Well, regarding terrain analysis, also using both UAVs and AGVs, we are proposing here a topological study to analyze and better create the decisions for robot mobility in the TALOS project. And with this, we are looking for a system that must do a visual analysis of the terrain applied here for both the land-based and the RVPV pilots. We also want an engine that can give recommendations for safe robot operations and a detection, basically a system that can detect also different types of changes with the time. So we need to identify obstacles, landslides, anything that can be captured using a system, a lidar system. And all of this should have the capacity to integrate with the TALOS platform, and also it must be validated in one of the TALOS pilot sites. And as a preferential requisites here, we are looking for algorithms that can analyze the terrain data, and of course the communication with the TALOS platform as seen in previous challenges.
The fifth, we want to have a robot that must be able to inspect the back sheet of PV panels. This is something to be applied for the conventional PV and also for the agri PV. So the idea is to have an autonomous ground vehicle that can do these inspections on the back sheet of the panels, for instance, using some thermography cameras, but can also identify electrical wiring connections, some loose cables that may appear, so we can detect and send some alerts to the O&M teams. So as mandatory requisites, we want to understand again we want to identify these electrical wiring connections. We want to perform visual and thermal inspections of the backsheet of these panels. The integration and communication with the TALOS platform is something mandatory, so it should be all integrated with the TALOS platform and must be also validated in one of our pilot sites. As preferential requisites, the identification of loose cables or hanging elements, and the autonomous identification of defects of the PV panels using the inspection on the backsheet part of the panels.
Now, for number 16, we have here a proposal for, well, a challenge here for the agrivoltaics pilots, and which is basically an AI microclimate monitoring and recommendation system. So this should basically provide recommendations for both farming and optimization of the water usage in these type of pilots. And for this, we have some mandatory requisites, such as the algorithms for crop data analysis, also a smart water management system to optimize all the crop irrigation, and a recommendation engine for the farming activities that should be performed at a specific time given the specific weather conditions. And this solution must be capable of being integrated with the TALOS platform and validated in an equivalent pilot site. And as a nice to have, we propose here the construction of structures to collect all the rainwater and to also reduce the water usage in itself. and reuse this water in other applications. For example, in the cleaning of the PV panels in these types of pilots. And we are looking for also the communication with the TALOS platform and the validation in our TALOS pilot sites, in this case, the APV.
For the 17th, we have autonomous agricultural practices for per orchids. So this is pretty much related with our AgriPV pilot. And the idea is to have an autonomous ground vehicle that can perform different agricultural practices such as pruning, thinning, spraying, fertilizing, or even harvesting without a human intervention. As mandatory requisites, the solution should have some algorithms that could identify these areas of action for the agricultural practices. It should have at least, it should give an answer at least for one of these practices, but try to be again bold and ambitious. Then it should have the capacity to integrate in with the TALOS platform and could be validated in other pilot site that is equivalent to the per arcade that we have in the Netherlands. As preferential, we have the communication with the TALOS platform and the validation in the AgriPV site.
And now we have a very interesting challenge here, which is the cleaning of the PV panels above the fruit trees, so the pear orchids in this case. And basically what we want to have is a system that can perform the cleaning autonomously. And it is very challenging with the structures in itself that are applied to the agrivoltaics pilot, the one in the Netherlands. But these types of solutions must not damage the crops, neither the soil beneath and around the panels. That's why it's so challenging. And given the height, it is an additional type of performance that you must be aware of. And we want also this system to be able to be integrated with the TALOS platform, and we want a validation in our AgriPV TALOS pilot sites. And preferentially, we are looking for a water management system for this for crop irrigation, basically, and also communication with the TALOS platform. And now moving to the last,
Yeah,
but not
this is
least.
yeah, exactly. This is the last challenge, which is this open topic. So we are considering the previous 18 because they were basically the needs and the pains from the pilot owners, the asset owners. But of course that we are open to other solutions that can be tailored to this project and that would address any kind of topic that is related to sustainability, biodiversity, O&M activities, etc. And the requisites that are here are very generic. So again, if it is a digital solution, we want to have a solution that is capable to integrate with our platform, and the validation of this idea can be performed in other pilot site that is equivalent to ours. I mean, this is something that you can propose new ideas, other very I don't know, very disruptive technology that you want to test here. It would be very great to see as well. So yeah, this is just an open topic. If you have good technology to show us, please feel free to apply within this topic. I think from my side, that's it, Yolanda.
Thanks so much, Daniel, Claudia.
Thank
That
you.
was really interesting and very explicative. So thank you for this presentation. And I think that now we can go for the questions that our attendants have. Laura, sorry, Anna?
Yes, thank you, Daniel, Claudia, and Yolanda. I see that we have some questions here. What expenses are eligible for the project?
Okay, well, Talos is an Horizon Europe project, so the main cost categories that we cover are the personal cost, the people that is going to be working in the development of the project, the purchase costs that are necessary for developing it. We have travel, equipment, other goods that are necessary. The 200,000 euros is calculated because it's supposed that for this kind of solutions, it will be like a high expense in equipment. So that is like one of the main costs. Also, it could be included as subcontracting cost, but never over the 5% of the total cost, okay? And always this subcontracting cost will be studied case by case because, for example, you cannot subcontract one of the main tasks for the development of the project. Then, being this Horizon Europe project, as said, you will have to add like the overheads. That is the 25% of the sum of the other categories. You in the frequently asked question documents, you will find a couple of examples of budgets, and here you have like the main cost categories that you can include. Also, we need to say that in the application stage, it's not necessary to develop a detailed budget, only an idea of it. And if you are selected during the first stage of the project, when creating the individual mentoring plan, your mentors will help you in create this detailed budget.
Thank you, Yolanda. Another question, is subcontracting allowed?
Okay. Well, I said yes, but with conditions. It cannot be more than the 15% of the project, and it cannot be for one of the main tasks.
Thank you. Question, will the funding be handled as lump sum? In other words, will the beneficiary have to claim costs through financial reports?
Yes, the support program will be with lump sum. And well, for those one who doesn't know, lump sum is a simplified method of setting expenses in the projects financed European Commission, and you will need to create this budget at the beginning of the support program, but then you will not need to provide the financial records. You will need to demonstrate the implementation of the project. And when you fulfill the milestones and KPIs that are set for the project, you will receive the amount. But we will not review your accountancy. We will review your work for the project. So yes, lump sum.
Thank you. I think that we have a question for Danielle or Claudia. The depth of the operation of underwater cable inspection was not specified. Example, 9 meters is depth enough?
So this challenge is similar to the other one pertaining underwater activities, and for both of them, the max depth is around 100 meters.
That's the maximum depth that we are considering here.
Another question, maybe I missed it, but this is opportunity for single applicants, or it is okay to have consortiums of SMEs?
No, we can only have individual entities, individual startups or individual SMEs.
Thank you, Yolanda. I thank you for your presentation. Are the TALOS Brain platform specifications already available?
Well, I can go. We have not published yet the documents of the open call. I guess maybe by the end of next week, we will have them in the application site.
Thank you. Will it be possible to test solutions in the pilot sites during the development, not only the final validation?
I believe so, yeah. Yeah, there's no problem at all, I believe.
If we develop algorithms for robots operating in the pilot sites, will it be possible to have access to these robots and data during the development, not only the final validation?
In principle, yes. Yes. You'll have access to all the data.
Is there any
I
limitation?
mean, at least the data that we are also collecting. We may have some problems also from our development side, but at least the ones that we have, they will be open to the open call beneficiaries as well.
Thank you, Daniel. Is there any limitation to participation in other EU projects? No double funding, of course. More precisely, we have been selected in Co-op project, and it seems that TALOS is somehow related to it.
If now double funding, there is no problem. Corop and Talos belong to the same program inside the European Commission, but if you are selected during the formal check, we will check that there is not double funding, that the projects are different, and there will be no problem.
Thank you, Yolanda. When will be available for download the guide for applicants and the other open call documents? Will we be able to access the presentations from the session?
As said before, I hope that by the end of next week, all the documents will be available at the application site. And yes, the presentation of this session and the video will be also available. And I think you will receive an email with this information and also with the invitation to the following webinars.
Thank you, Yolanda. I don't see any other questions at the moment.
Well, if you come up with any other question, please send it to us, to the help desk or to the Discord help desk channel, and we will be happy to answer it.
Oh, I see another question that just came in. Where can we find some technical data about the TALOS platform and integration with it?
That will be also an annex to the guide for applicants, the requisites for the platform.
Thank you, Yolanda. I don't see any other question.
Well, if that's all, I think we can close the session. Thanks so much, especially Claudia, Daniel.
Thank
you
so
for
much.
being here and for all the explanation. And thank you to all the attendants for your interest.
I think that there's other question. Sorry
Yes.
to interrupt.
Yeah, maybe you can have this last question. Can SMEs from EU associated countries apply?
Yes.
Okay, I don't see any other questions for now. But as Yolanda said, if you have any other questions, you can reach us at the help desk or send us an email.
Okay.
Okay, thank you, everybody.
Thank you so much.
Thank
Bye-bye.
you.